On this channel, we provide useful programming information with practical code examples. This time, we will discuss ArrayBuffer in TypeScript. We will explain ArrayBuffer in TypeScript step by step, covering basics to practical techniques. Enabling subtitles will make the code descriptions easier to understand. ArrayBuffer is a built-in object that represents a raw memory area for binary data. It represents a raw buffer of fixed length, upon which typed array or DataView are layered for reading and writing. ArrayBuffer is a fixed-length byte sequence. You specify the size in bytes when creating it, and its length cannot be changed afterward. This code creates an empty buffer of 16 bytes. You can check the size using byte length. ArrayBuffer does not have the ability to read or write data. Therefore, actual operations are performed through typed array or DataView, specifying types such as integers or floating point numbers and Endianness when accessing data. uint8 array is a byte-wise array view, and can be accessed like a normal array. If you place multiple views on the same ArrayBuffer, they share the same memory for reading and writing. DataView is useful for fine-grained reading and writing by byte, and allows you to specify little or big endian. DataView allows you to read and write values by specifying offsets in memory, making it suitable for implementing protocols that require handling network byte order. To convert text to binary and vice versa, use TextEncoder and TextDecoder. TextEncoder encode returns a uint8 array, so if you need an ArrayBuffer, you should refer to its buffer property. With the slice method, you can extract the required data by specifying the offset and length. The slice method returns a new ArrayBuffer. ArrayBuffer cannot be resized. If resizing is necessary, create a new buffer and copy the data into it. Since the slice method returns a new ArrayBuffer, if you prioritize efficiency or sharing references, you can use the subarray method of typed array to refer to the same buffer. TypedArray.subarray returns a new view that refers to the same ArrayBuffer. Shared views can avoid the cost of copying, but since they refer to the same buffer, you need to be careful about side effects. Since ArrayBuffer is of fixed length, to combine multiple buffers create a new ArrayBuffer and copy the data. If you frequently concatenate large amounts of data, precomputing the total size and allocating a new buffer only once, as in this code, is more efficient. In the browser's post message, you can transfer an ArrayBuffer as a transferable object. Ownership can be transferred without copying, which avoids the cost of copying. By specifying the objects to transfer in an array as the second argument of post message, you can transfer ownership, without copying, of transferable objects such as ArrayBuffer. After transferring, the buffer becomes detached on the original side and cannot be accessed. Using shared ArrayBuffer allows simultaneous access from multiple threads, but its use comes with security requirements and environment restrictions. In Node.js, you can convert between the Node.js binary type, buffer, and ArrayBuffer. This is useful when targeting both browsers and Node.js with TypeScript. Buffer. From ArrayBuffer, in Node.js usually creates a copy, but there are cases where reference sharing is possible, so be mindful of offsets. To optimize performance and handle ArrayBuffer efficiently, there are several important points to keep in mind. Below, we list and explain practical best practices. Reduce the number of copies. When handling large binaries, use subarray, shared view, or transferables to reduce copies. Allocate large buffers at once. Allocating small buffers repeatedly increases overhead. If possible, allocate a large buffer at once and use portions of it as needed. Specify Endianness explicitly. When handling multi-byte values, use DataView and explicitly specify Endianness. Big endian is often standard for network protocols. ArrayBuffer is widely used both in browsers and Node.js. The following code is an example of acquiring and analyzing binary data. This code fetches binary data from any URL in the browser and displays the first few bytes. The code loads data fetched via the fetch API as an ArrayBuffer and inspects the first 16 bytes with a uint8 array. ArrayBuffer is a raw memory representation, enabling efficient binary operations via TypedArray and DataView. By designing to avoid unnecessary copying and explicitly specifying endianness, you can achieve safe and high-performance binary processing. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. See you in the next video. Please subscribe and give us a thumbs up.